Okay, let's take a look at problem number 19 in section 8.3. Anna is buying $15,000 worth of rare coins as an investment. The dealer is charging her an annual interest rate of 9.3% and is using an add-on method to compute her monthly payments. If Anna pays off coins in 48 months, what are her monthly payments? If she makes a down payment of $2,000, how much will this reduce her monthly payments? If she wants to have monthly payments of $350, how large should her down payment be? All right, let's take a look at part A. We are asked, what are her monthly payments? So monthly payments, that is the future amount, the total that we're paying, divided by the number of months. The future amount A is the principal plus any interest that we're charged to borrow the $15,000 for rare coins. The interest formula for simple interest is P times RT, right? And this is simple interest. Now, in our example, P is that $15,000. So I is PRT, which is 15,000 times the rate, times R, which is 9.3%. So for your calculator, that's in decimal form, 0.093. And then we'll also multiply by the amount of years. Well, they don't straight out tell us how many years there are, but they do tell us 48 months, right? And 48 months is 4 years. So we'll put in times 4. So using our calculator, we have 15,000 times 0.093 times 4. And it seems as though she's paying $5,580 in interest, right? So this is dollars, note to self. Now, that's the amount of interest that they're charging her to borrow the $15,000 for the coins, right? So in total, the future amount will be the principal that she's borrowing plus the interest that they're charging her, right? So we take the $15,000 and we add the interest, the $5,580, and we find that she's going to owe them $20,580. But we're asked, right, what are the monthly payments? The monthly payments are the future amount divided by the total number of payments. So if she ends up paying $20,580 for the coins and she pays them off in 48 months, then in total, she's going to end up owing them that's just the interest a month. She's going to take $20,580 and pay that off in 48 months. She's going to owe them $428.75 each month. So that's her monthly payments. Okay, now let's look at part B. If she makes a down payment of $2,000, how much will this reduce her monthly payments? Well, we had a principal of 15,000, and if we pay 2,000 first, then now we have a principal of 13,000. Following the same steps above, we can determine how much she owes now and the difference, right? Another version of A is P times 1 plus RT. That's the future amount, right? So we'll use this version to use the 13,000. 1 plus RT above is the 1 plus 0.093, and t was 4, right? So 1 plus 0.093 times 4. So if we take that into the calculator, we put in 0.093 multiplied times 4, hit enter, and then add 1, hit enter. So what we have is that the principal, the $13,000 times 1.372, because that's the principal and the interest being multiplied together, multiplied and added together. Okay, so put this into the calculator and we get, so 1.372 times 13,000 is a grand total of 17,836. So in part B, if she pays 2,000 up front, now she only owes $17,836 in the end. But we want to know what the monthly payment is, right? The monthly payment is going to be the future amount divided by the number of months. The future amount is 17,836, and we're still paying that off in 48 months, right? So divide by 48, and now put this in our calculator, right? 17,836 divided by 48, and we get 371.583333, and we have to round. So we're going to round to 371 to the nearest cent, 58 cents. This is her monthly payments. Now, the question though said, how much will this reduce her monthly payments? If her monthly payments were previously 428.75 and her monthly payments are now 371.58, then she's saving how much money a month by making a $2,000 down payment? 428.75 minus 371.58 is $57, and I always do the percent sign, $57.17 saved per month. All right, now let's look at part C. Part C tells us if she wants to have monthly payments of $350, how large should her down payment be? So now we know exactly the size of the payment that we're looking for. We got it down to $371, paying it off, paying down $2,000, right? So I imagine it's still somewhere in the $2,000 range or close. Let's see. So let's set up our equation. A over N is our equation for monthly payments, and we know what we want the monthly payments to be, $350. So A over N, which is $350 for starters, right? We also know that A over N is the principal times, so the principal times 1 plus RT, right? But the principal will be reduced by some down payment, right? So I'll call that down. Now in part B, we reduced P by 2,000. This time we don't know what we're reducing it by. We do know that P itself starts as 15,000, right? And we know what 1 plus RT is because we solved it in the problem above, right? We have 1.372 because that was 1 plus 0.093 times 4. Now, if we put these two together, what we have is A over N in the form of $15,000 minus the down payment times the 1.372. We have that is the monthly payments. Oh, divided by N. Divided by N. Not monthly payments yet. Okay, there we go. Divide by 48 months. Divide by N. Divide by N. Got it. So this divide by 48. Okay, so we're looking at monthly payments. And we also know that that is supposed to be $350. So this is the equation that we're looking to solve. So if we try to solve for the down payment, we will multiply both sides by 48. We will then divide by both sides by the 1.372. We'll subtract that 15,000 from both sides, leaving us with negative down. And then we'll have to multiply the negative by both sides. All right, so we'll take 350 times 48 divided by 1.372, and then we will subtract 15,000 to get the opposite of the down payment. But we don't want the opposite of the down payment, right? We want the down payment. So if we multiply both sides by negative, then this negative goes away, and we end up switching the order of this side so that the 15,000 is the primary, and we take away the 350 times 48 divided by 1.372. So let's see what her down payment should be. So if we type it in here, then we have 15,000 minus parentheses 350 times parentheses. I have an 8 in there, so I did something wrong. Let's start over. 15,000. Look at this. Okay, there we go. 15,000 minus parentheses 350 times, there we go, that's what the 8 was, times 48 divided by 1.372. Let's see what this is. 2,755. Pretty close to 2,000, right? That's what we were telling ourselves to begin with. So we found that if she makes a down payment of $2,755.10, she could bring her down payments down to $350.